Well, I saw this interesting integral, and I have a different methods. It's worth sharing here. Now, I started with this. Well, I, as we know that this integral, we must learn it, from by parts. This integral is equal to this, right? And plus c. Well, this is the antiderivative of log x. So I can do this by split this one into dx log x minus x, because this one is log x dx, which is equal to this. Now I can start by parts. U dv, right? So this is v, and this is u from 0 to 1 minus v du, the integral. V is this, du is 1 over x squared dx. Well, for this one is x equal to 1 is 0. This is a 1. This is a quarter pi. So equal to, again, negative quarter pi. When x equal to 0, when x equal to approaches to 0, rather, this one could be used L'Hopital's rule, right? We can easily develop, let's go to 0. So this is go to 0. Everything go to 0. Okay. So that's for this one. Now for that one, I write this negative first. So it become positive, right? So integral x over 1 plus x squared from 0 to 1. The other one is negative 0 to 1, and x log x dx 1 plus x squared. Well, good. So this will go negative quarter pi plus, this one's easy. This one is equal to 1 half d1 plus x squared, right? 1 plus x squared minus, I call this one j, just develop separately. Now this is minus quarter pi. This one is plus half log 1 plus x squared from 0 to 1, from 0 to 1 minus j. So my integral I is equal to quarter pi negative. This is a log 2, right? Plus half log 2 and minus j. I just finish j, I'll finish my I. So j is equal to this. J is equal to integral from 0 to 1 x log x 1 plus x squared dx. This one is equal to integral x log x. 1 over x squared is a power series, right? From 0 to infinity minus 1 to the power of n and x to n, right? Yeah, dx. So, okay. Well, because in this interval, x squared is always less than 1. Therefore, this power series is valid and convergent. So, so my integral becomes integral sigma notation negative 1 to the n from 0 to infinity, 0 to 1. This becomes x to n plus 1, right? dx. No, there's a log x. Sorry. All right, now here I try to set by parts. So this one, well, because this is good for this convergent and finite, therefore I can switch that from 0 to infinity, minus 1 to the n, and the integral log x, and this I can write as a d x to 2n plus 2 divided by 2n plus 2. Here I just prepare for by parts. So this one is equal to sigma from 0 to infinity minus 1 to the n. This could be taken out. And that is good for by parts, u dv. Right? So it's u, that is this one, times v minus v du. V is this. V is this. X to n plus 2. Du is 1 of x. Wow, it's good. And this is sigma 0 to infinity 2n minus plus 1. Now, when x equal to 1, no problem. It's to 0. When x equal to 0, well, this is x to n times x, right? Times log x. Now x is approaching to 0. Then this could be written as a log x 1 of x, right? So we can use you can use by L'Hopital's rule. So this one's go to 0 anyhow. No, it's very easy. You can finish by yourself. So this one, whole thing go to 0, right? So yeah, and minus integral 2n plus 1, yeah, dx. Very good. So this was a sigma 2n plus 1, 1n. That integral is equal to 2n plus 2, correct? X and 2n plus 2 into 1. So it's end up with 1 on top. So it becomes sigma from and 2n plus 1 square. Is that correct? Yes. All right. Finally, we just evaluate this pulse series. Now, how do we calculate this sigma n from 0 to infinity? Well, no, we are, this is j, right? We just put it, yeah, this is j. You calculate j. Okay, then how do we calculate this one? Mm, well, this one time this one is 4, right? So I'm missing the 4 here. This is 2n plus 1 bracket, right? So it becomes a 4. 2n minus 1 square. Yeah, that's correct. So let's continue. J is equal to, I take 1 over 4 out, 0, infinity, n minus plus 1 square. Well, we have a negative here. I forget a negative here. There's a negative here, right? So there's a negative here. Oh, sorry. There's a negative here. There's a negative here. I just confused with this. So it becomes that, it becomes 1/4 sigma from 0 to infinity and n to the power n plus 1, n plus 1 square. Yeah. So this one is equal to 1/4. I replaced m by n for m plus 1. So it becomes that m to minus 1 to m and m square. This m is from 1 to infinity. Yeah, that is better. Okay. Then what? Now I tried to calculate this one without using sophisticated functions. Now let me show this one. This m equal to 1 to infinity, m squared minus 1 to the m. This one is equal to, the first one is minus 1, right? Then plus 1 over 2 square. Then minus 3 square plus 4 square minus 5 square and plus 6 square and so on. If I take negative outside, negative m equal to 1 m square, then change the sign, right? It becomes 1 minus 1 over 2 square plus 1 over 3 square minus 1 over 4 square plus 1 over 5 square minus 1 over 6 square and so on. This one is this. Take away those reciprocal of odd numbers, and take a 1 is not enough. You have to take a 2, to make this alternating. You have to take a 2 series of reciprocal of even numbers. Yeah. So this one we know. This one is a Basel problem, minus pi squared over 6. Minus 2. This one is equal to 1/4 times another Basel problem, right? So this one equal to pi over 6, pi square over 6, sorry, pi square over 6 minus 1/2 pi square over 6. So that was equal to, equal to 12 pi square. That is equal to this. But don't worry, there's a negative here. See? So we're looking for this, right? We are looking for this for j. J is equal to negative that. So j is equal to negative pi square over 12. See, j is equal to this. This one is this. And we calculate negative of that. Negative of that is equal to this. Therefore, this is equal to negative square pi square over 12. So let's see what is our target integral. Target integral is this. Our target integral is equal to minus pi quarter pi plus half log 2 minus j minus 4. J is equal to what? J is equal to 1/4 of that. This is this, and j is equal to 1/4 of that. So plus 1/4. This is negative, right? So 1/4 of pi square over 12. So finally, this is equal to 1/4 pi plus log 2 plus 48 under pi square. So that is the very result. Yeah. Because we have a negative j. I is equal to this negative j. Negative j, right? This is a negative this times negative quarter. So it becomes positive. Wow, what a confusion.